Hello, and welcome to another lesson on 5-1, the unit circle. Today we're going to talk about reference numbers in reference to the unit circle, no pun intended. Reference numbers, or in this particular case, we're going to call this T-bar because we're going to use actually the symbol T with a bar over it. If you remember, we had T-values. T-values is the last lesson we learned where we had all of these radian measures, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, etc., all the way around the unit circle. We call these T-values, okay? And that is different from, these are your terminal values, and that's going to be different from T-bar. T-bar is a very specific, there's a very specific definition for it, and we'll get into it, but it's denoted with the bar above the T, is why we call it T-bar. So T-bar is what we're going to call it in this particular lesson, or reference number. And this is the shortest distance, by definition, the shortest distance. Let me zoom out a little bit. It is the shortest distance along the unit circle between a terminal point, which we just talked about, between a terminal point and the x-axis. So what this means is this. You see you have the pink circle, we have the unit circle here with the radians, and we have the angle measures here. We're going to be talking about, we're going to be using that. It's in pink, so you don't have to copy that down. We already have that. We're going to be talking about 4 different scenarios in which this could possibly happen. So, first scenario, and let's try to illustrate this as best as we can. Let's draw a unit circle, roughly. That looks terrible. Let's try that again. Okay. And we have a unit circle here, and we would normally have a t-value. So I'm going to put I'm going to put a terminal point here, and we have some distance along the unit circle where we would call this just t, your t-value. How many radians from the origin, or from our initial point to our terminal point, what is that distance? So the reference number, or the T-bar, I'll do this in blue, is the shortest distance from this point back to the x-axis. Now there are 2 ways to think about this: taking this terminal point and going left to the x-axis, or going to the right to get to the x-axis, okay? And in this particular case, if our t-value is in quadrant 1, the shortest distance to get back to the x-axis is actually to go backwards. So, in this particular case, T-bar is actually, let's do this in blue because we're actually talking about T-bar, and I said that we'd do it in blue. T-bar is actually equal to T, because that is the shortest distance to get to the x-axis. We want to get back here, and we would travel the same distance back. Okay? So, second scenario is when we actually land in the quadrant 2. So let's draw a second situation. We're going to draw another unit circle. And what happens if our t-value lands in quadrant 2? Well, the shortest distance to the x-axis is no longer going backwards, but it is actually going forwards. So, if we think about this, we want to get all the way to pi. The way we would do that is this. We know that the full length of half of a circle is pi, so we could think of it like this. T-bar would be equal to pi minus the actual t-value. So this is, like I said, remember this is t, the t value. We would take pi, which is the whole length, subtract t, which is the red length, and that would give us the blue length. Okay? So that is how we could solve t bar if our t value lands in quadrant 2. If our t value lands in quadrant 3, so we're going to draw another circle. And then remember, these are just rough sketches. Hopefully we have enough room. If we have a unit circle here, and our t value wraps all the way around into quadrant 3, our t value wraps all the way around, and we want to get back to the x-axis. Pardon my voice. So what we need to do here is actually consider this. We need to consider that this entire length, let me use a laser pointer. This length here is equal to 1 pi because it's half of a circle, okay? But we want to actually cut this out because we are only concerned about this distance in blue. So the way we would do that is we would actually label t bar would be equal to t, which is the entire length around, and we would subtract pi. Because when you subtract these two, it actually gives you only the blue length. So t minus pi in this particular case will give you t bar. Hopefully that makes sense. I will show you an easier way to do this, but this is just more logistically, how does this make sense? Okay. Last scenario, remember this is quadrant 3. Last scenario is in quadrant 4. What happens if a line or if a t value lands in quadrant 4? Well, let's draw our half circle or our full circle. And if we wrap all the way around into quadrant 4, the shortest distance back to the x-axis would be to complete the circle, okay? So in reality, we're thinking about this. We want a full circle around. That's 2 pi. But we actually want to cut out the red. If we cut out the red, that would give us blue, right? Take the purple, that's just 2 pi. Cut out the red, which is whatever the t value is, and that will give us blue, okay? So the equation for this, logistically, would be t bar is equal to t, the t value, 2 pi, minus the t value. Because we want the whole circle minus the red is equal to the blue, right? So that's your 4 different scenarios. We want to find the shortest distance to the x-axis, okay? And let's do a couple of examples to better illustrate this, and I'll show you actually a better way to think about this. So if, for instance, we have an example A, what is the, let's say, we're going to say find the reference number to each t value. Now, in A, I'm going to say pi over 3, okay? If our example is pi over 3, we want to locate that on our unit circle. So let's do it really quickly. All right, in pink, we have our unit circle, and we could find our pi over 3 right here. Notice that it lands in quadrant 1. So like our first example here, the shortest distance back is to just use that exact t value. So since it's from the initial point to pi over 3, that's the distance along the unit circle. To go back would be that exact same length, pi over 3. So remember, all of these values refer to how far we're traveling along the unit circle. So in this particular case, we travel pi over 3 units. We would travel back pi over 3 units, and that would be our t bar, okay? So t bar is equal to pi over 3. Let's try another one. b. What if we have 5 pi over 6? Well, let's find 5 pi over 6. 5 pi over 6 is in the second quadrant, 5 pi over 6. So our t value would wrap all the way over here to quadrant 2. But the shortest distance to the x-axis would actually to be traveling this distance. And if we think logistically, or if we think using our actual angle measures, isn't it from 150 degrees to 180 degrees? Isn't that only 30 degrees to make up? So this is how I want you to think about this. If this is 30 degrees, that distance is the same as if I were to travel 30 degrees this way. Okay? So in reality, this distance is pi over 6. And I'll show you both ways on how this would go. But realistically, since the 30 degrees traveling is only pi over 6, the t-bar should be equal to pi over 6. Now remember how I said this also? You could technically take pi and subtract t. In this particular case, we would say t-bar is equal to pi minus 5 over 6 pi. Well, in order to properly do this, and if we want to, we could actually just do this in pink because this is a secondary example and a second way to solve it. So if we did this in pink, 1 over 1 minus 5 over 6, we would actually need to convert this to 6 pi over 6 minus 5 pi over 6. And then, because we need common denominator, what's 6 pi minus 5 pi? 1 pi over 6, which is what we initially solved for. 1 pi over 6 is the same thing as pi over 6. So, depending on how you want to approach this, if you notice that this distance is equal to 30 degrees, you could look up 30 degrees on our from our initial point to 30 degrees, and that is the exact same distance. Okay? Let's try another one. C. Ooh, that's in pink. Let's try another one. C. Let's say 7 pi over 4. Let's find 7 pi over 4. 7 pi over 4 is all the way down here, so that we're in quadrant 4. So that distance would wrap all the way around. This is our t value that wraps all the way around to 7 pi over 4. And we want to make up this distance because that's the shortest distance to the x-axis. So 315 degrees all the way to 360 is 45 degrees. So what I'm going to do is I'm going to look at our quadrant 1 and look up the distance of 45 degrees. From 0 to 45 degrees is pi over 4, and that would be our shortest distance. That would be our t-bar. So we could say t-bar is equal to pi over 4. Okay? Last example. What happens if, let's say D, let's say t-bar is actually, or t is equal to, not D, equal sign, that should be a close parentheses. Let's say t is equal to 5. Now, we haven't really talked about this in terms of a radian measure, but if you recall, when we talked about radians could be written in terms of pi, and radians could actually be in terms of a number. So we know pi is actually equal to 3.14, right? And if we travel 3.14 in the unit circle, that lands us on 1 pi or the 180 degree mark. And we said that 2 pi is 6.28. So that's how we travel around this. 6.28, 6 would be right here. 6.28 makes the full circle, right? So if it's 5, that means we are landing approximately in quadrant 4. And that shortest distance would actually be to travel the rest of this way. Well, like I said, the circumference of a full circle is approximately 6.28, a whole circle. So we would take that concept, which is much like this one, and we would want to travel the rest of this distance. And instead of using 2 pi, we would actually use 6.28 here. So we would say 6.28 minus the t value, 5, is equal to our t-bar. 6.28 minus 5 is 1.28. So we would say t-bar is equal to 1.28 in this particular case. When things are not written in pi, if it's given as a number, you would want to look at the unit circle as if it is as if it's numeric, which is this version of the unit circle. All right, so I know that was a lot, but if you do have any questions, please ask, and I'll happily answer your questions. And I'll see you in the next one. Bye.